So we've talked a bit about data so far. But what is data? Well, if we go to the Cambridge Dictionary, they define it as information, facts or numbers, collected to be examined and considered, and used to help decision making. Or it could be information in an electronic form that can be stored and used by a computer. Merriam-Webster defines data as actual information used as a basis for reasoning, discussion, or calculation. I'd like to provide emphasis on a few key words. Information used to help decision making. Information as a basis for reasoning. Data on its own does not provide a story. It is the basis upon which we will build our stories and build our public policy recommendations. But in order to process data and provide those conclusions, we need to work with data sources. So what is a data source? In the abstract, a data source is self-descriptive. It's the source that contains a collection of data. For example, we could have comma-separated values or CSV files. We could have Microsoft Excel files. You might have worked with databases. There are also application programming interfaces from websites. For our purposes of this course, data sources are the services or repositories which contain the data files we will use for our analysis. So some examples of places online where you can find data sources are Canada Open Data. Many municipalities are creating open data portals. For example, the City of Toronto. Provinces in Canada generally have open data catalogs. The World Bank provides an open data bank as well, and the United Nations has the UN data. So if data sources are the long-term repository of data, in other words, where the data files are stored, then our data files are the files which we extract or create from those data sources. Now, the format in which that data is stored might be different from the original source. And there are two main types of data files that you'll run into. First are structured data files. These are files that are in a format that is easy to read by a computer. There's also unstructured data. It's got to be translated in some way in order to be useful in data analysis. You've likely seen structured data before. Have you opened a Microsoft Excel file or used a database? Well, then you've used structured data. In this course, when we talk about structured data, we're referring to data which follows a table-like format. Think spreadsheet. You have named columns and rows which contain data. On the Learn website is a file called table2minwage.csv. This is a comma-separated value file, and it's an example of structured data. You can see that we have columns that have labels, and we have rows with data. On the opposite end of the spectrum, we have unstructured data. This is data that cannot be easily mapped into a table format. So some examples include this video you're watching right now. This is unstructured data. If you were to get a transcript of this video, you could potentially turn that transcript into structured data. For instance, maybe you wanted to count the number of occurrences of the word data in this video recording. The video recording itself is not structured, but it could be translated into structured data through conversion. Voice recordings, emails, PDFs. These are all examples of unstructured data. It may be possible to transform these into structured data, but it's beyond the scope of this course. We're going to be working with structured data. And in order to work with structured data, we need to get to know our data sources. When you're working with a data source, there are many questions you want to ask. For example, what is the range of valid values? Say you're working with a file that has temperature data. It might be nice to know that the data will range between -50 and +50 Celsius. This gives you a clue for when you have bad data. Other questions to ask: what are the units of measurements? Do units change over time? What do unknown or missing values look like? In some systems, 0 can mean 0, but 0 can also mean unknown. Some data sources use other values for missing or unknown data, such as unknown, missing, null, or very large or very small values. We'll see examples of sentinel values in a future week. If we have multiple files in our analysis and we want to combine them, are the definitions the same across our data files? Say, for example, we have two data files that have a column called region. And in that region, both files have a region called northern. Is the region northern the same across both of these files? Do they share the same boundaries? You'll want to know how prevalent data issues are in your data file. For example, say your data file has more than 50% of the rows having missing data. Should you even use that data source? When you're cleaning your data, how do you handle missing data? How do you handle invalid data? Do you substitute values? Do you try to infer or interpolate between values? Or do you drop values? And what influence will your decisions have on your final results? These are all questions that you'll ask yourself as you get to know your data.